Okay, so average velocity then we're going to define as the average displacement traveled during a certain time interval. It's like distance, but it's different because I've got a displacement now instead of a distance. And remember, the difference is that the distance is the length of the path that I traveled to get from my final to my initial position. The displacement is the actual distance between my final or my actual number of units between my final and initial position. Okay, and notice that we're defining this a little bit differently here. We're saying the change in x, okay, meaning x minus x0, final minus initial position. And so, just like with distance, I'm going to ask, does this term imply a direction of motion, why or why not? And we, again, remember that because I am using displacement instead of distance, displacement requires a direction. I'm either moving in the positive or negative direction. So velocity also requires this need for a direction of motion. Okay, so I've got a fairly lengthy description here that I need you to write down and understand. So, yes, in contrast to distance, which is simply the absolute number of units traveled, displacement is the number of units separating the initial and final position in a direct line. This is often a smaller value. Okay, this is often a smaller value than the distance traveled between the initial and final position. Also, displacement has direction. If the final position is more positive than the initial position, the direction of motion is positive. If the final motion position is more negative than the initial position, the direction of motion is negative, indicated by a negative sign. As the displacement can either be in positive or negative direction, velocity can also be in a positive or negative direction. Okay, and we would then, and let me just go to our previous diagram. Again, you don't need to have drawn this, but now I'm going to say my velocity equals change of position, change of x divided by time, and change of, again, means final minus initial, my final position minus my initial position. And in this case, we're going to say that our displacement is 10 meters from the initial to final position. So I'm going to say 10 meters minus 0 meters over, and we said it was 10 seconds, so that equals 1 meter per second. So my velocity is quite a bit different here than what my speed is. Okay, my velocity was only 1 meter per second, and it was in the positive direction. Okay, and my speed was 10 meters per second, and it's not in any direction. It just is 10 meters per second. Okay, that's the rate at which it took me to go through that path. But to get from point 0 to point x, or x0 to x here, as far as velocity goes, I went 1 meter per second. Okay, and that may be a little bit confusing. Okay, likewise, if I make it x0 over here, if I say this is my initial position and this is my final position, then I would say v equals delta x over t equals x minus x0 over t equals 0, which is my final position, minus 10 meters, which is my initial position, divided by 10 seconds. And so my velocity in that case would be negative 1 meter per second. Okay, so please make sure you understand the difference between distance and displacement, and then also speed and velocity. Okay, so going back to the discussion here then, So what does this say about the sign of velocity? Well, what I want you to write down, pops up, the sign will be positive or negative depending on the direction of the displacement. Okay? So go ahead and write that down. And again, you can just pause the video while you're writing things. Are average velocity and average speed the same thing? Obviously, they're not. And here's what I want you to say to that. The answer is no. Average speed includes the term distance in its definition, while average velocity includes the term displacement. As the distance traveled between the initial and final position can be much greater than the displacement, the average speed can be greater than the average velocity. Okay, so go ahead and keep this up. Pause the video while you're writing that down, and then I'm going to go ahead and continue on. So because I need to conserve time here as far as my timing of my videos go, I'm going to just keep going, okay? And then we can ask the question, why do we add the term average to velocity and speed? And think about it. If I am traveling a certain distance or I'm traveling a certain displacement, along the path, am I always going the same distance per second? Am I speeding up or slowing down? Am I going the same distance per second? And right now, all we can use to describe motion is just the velocity, and I don't know whether I'm speeding up or slowing down during that motion. So all I can do to figure out how fast I went along a path is take the total distance or the total displacement and divide it by the total amount of time. Okay, I don't have any way yet, but we will. I don't have any way yet to see into how the motion changes during the going along the path. Okay, but I will. So right now, I just have the term average for velocity and speed. And so what I've said here is the only information we have is total distance or displacement and the amount of time. We don't know if the rate of motion is the same throughout the motion or if in some parts of the motion the object is going faster or slower than in other parts. Only if we know the motion is constant throughout the motion can we leave off the term average. So the only way I can actually leave the term average off is if I know for a fact that the motion is constant throughout the motion. So go ahead and pause the video and write this answer down on your worksheet. And I do expect you to write out the whole answer, okay? And the reason for that is that I want you to think about this while you're writing it out, okay? You have to actually sort of put this into your brain in order to write out this whole explanation. Okay. Now, the last thing we can do as far as our velocity formula then is we can actually sort of expand it a little bit. We can say that delta x equals x minus x0 over time. And that's going to make this a little bit more useful, and you'll see how here as we go through a couple of problems. Okay, so if we go back to our problems here. Okay. So in the class notes, if you go to the Canvas page and for this particular lesson and you look in the class notes, there will be links to video clips, and the links to the video clips will show you how the problem works. I wanted to kind of do these a little bit separately so that you could just go to the link for a particular problem if you wanted to go back and look at it again, rather than having to go back through the whole video of the lesson. So I have, so wherever there's a problem number, that link will be to the video clip of that. And then I'll also have a solution to the video clip that you can just look at. Now, these won't always be the greatest form because I will have just written them from the video clip that I did, and writing on the computer is not always the cleanest thing to do, so they might be a little bit messy. So if you just look at the solutions, you're probably not going to understand it very well unless you've also watched the video along with it. So anyway, we're going to go through these little video clips, and I'll keep this recording going, but this will sort of be a recording within a recording, and because of the length of this first one, I will have to split it up into another video, and so but let's just go ahead and start. Okay, so I've opened up this video, and it'll be best if you put this in
this is the video clip
theater mode so that you can still see
the 1-2 rate of motion velocity
everything else.
Discussion. And we're going to begin to start to use a strategy that will help us understand how to problem solve in a much more effective way. And we'll try to use this strategy as consistently as we can, so that you get used to it and that you'll always be able to use it. Only later on, after we've really learned how to use the strategy, will I let you start to not use parts of the strategy. But anyway, let's see how this works. We've got a statement that says the position of a runner is plotted as moving along the x-axis of a coordinate system. During a 3-second time interval, the runner's position changes from x1 equals 50 meters to x2 equals 30.5 meters. What is the runner's average velocity? Okay, so the strategy that we're always going to use here to begin with involves a couple of parts. The first part is we're going to write down a frame of reference for the motion as it occurs. This is going to give us a visual understanding of what the motion is that's occurring, and it will allow us to collect all of the information we need to collect in order to accomplish solving the problem. Okay, so it's very important that we begin to do this as consistently as we can. And so here's how we're going to do this. Our frame of reference, for the most part, at least for one-dimensional motion, is simply going to consist of a line that designates an origin and a direction of positive x values. That's all we need to define motion. Okay, so this is the context that our motion is occurring in. Then once we define this, we need to collect all of the information that we can. And we're going to, and you don't need to write this down yet, but we're going to follow a pattern. Always we're going to follow a pattern. We're going to collect our initial position first, although in this case the initial position is x1 instead of x0. We're going to collect our final position. We're going to collect our initial velocity. We're going to collect our final velocity. We're going to collect our acceleration, and then we're going to collect a time. And always do this in this pattern so that we don't forget information. Okay, so if I look at the problem here, my statement will oftentimes be, I don't know how to solve this problem, but I don't care that I don't know how to solve this problem because my strategy will lead me through it. You'll never be able to say, I don't know how to start a problem.
Okay, now let's go to the next video at this point because we are running out of time for this video. So go ahead and stop this video, and then we'll come right back to this immediate problem here. Okay?